Welcome everybody. This is Unit 4, Day 4, Periodic Functions. And this is our last set of notes for this unit. And so we are just finishing up some pieces of information that we didn't get a chance to cover in our previous notes. I'm going to start today by going over some stuff from our investigation. And that is with taking a graph and writing the equation from a graph. So I'm going to start with not data like we did in our investigation, but with a normal graph. So with this graph, if I just give you a graph and say, hey, write the equation of this, you would want to decide for yourself whether or not you want to use a sine equation or a cosine equation. And in the investigation, we told you what to do. And now you have a choice. So that's a little bit harder when you are not told what to do. So I'm going to do both. I'm going to do cosine and I'm going to do sine and show you how you can do both. So what I would do for this one is I would look at this and determine that when you're crossing the y-axis, for me that's key, and look at where you're crossing the y-axis. And because this graph crosses the y-axis at the top of the hill, that's a big indication to me that a cosine equation would be the easiest. So what I just outlined is one cycle of a wave. And when it crosses at the top of the hill, that closely mimics the mother function for cosine. So I would start off by doing a cosine function. And so this is the basic formula for cosine. And then go through and do all the steps that we did in the investigation and find your A, B, C, and D. So remember, for some of that, you need to find your maximum and minimum points. So the top of this is at 5. The bottom is at -1. So to find A, you want to subtract those. So 5 minus -1, and take half. That's going to be 6 divided by 2. That's 3. So your amplitude is 3. With things that aren't data like we were looking at, it should be visually pretty easy, I hope, to see that the midline is right around here, where you've got half of your wave above this spot and half of your wave below. So instead of doing that work, you could just visualize where the midline is, and then once you identify that, you can just count and say that you've got 3 above the midline and 3 below, and identify your amplitude that way. And then once you identify the midline, you can say, oh, the midline's at 2, and that's going to be your D value. But if you want to use the max and min for that, then you can also do 5 plus -1 divided by 2 and do like we did in the investigation. And that's going to be 4 divided by 2, and that confirms that your midline should be at 2. All right, to get B and C, that's your period, comes from period and then the phase shift. So B, you cannot get directly. B comes from the period. So you need to figure out what the period is. So how far do you go along the x-axis to complete one full cycle? So that's what I did in green. To get from the top of one wave to the top of the next wave, that was along the x-axis here. That was 4 units. So one period is 4 units, and I set that equal to the period formula of 2 pi divided by b. So then if we solve that, we get that b equals 2 pi divided by 4, and so b is pi over 2. Now, in terms of shifting left or right, since we are crossing the y-axis at the top of the hill, right here, that means that there is no phase shift, because that is mimicking the mother function for cosine. So there is no c value for this. So our final equation is going to be y equals a cosine, b is 2x, and then plus d. Ooh, sorry, take that back. B is pi over 2, and then d is the plus 2. So that is your final equation. All right, I'm going to do the same thing, but I'm going to now do a cosine equation for this, or sorry, a sine equation for this. So let me pull up the graph again. Try to make it a little bit bigger. Okay, so let's say that maybe you didn't see that that could be a cosine graph. Again, I would probably start, just because I think it's easier, by putting in the midline. And so I would put a dotted line right here and say, oh, there's the midline. And so a sine wave, a parent function for sine always begins, if you think about the mother function, where it crosses the midline. So I might identify this by saying that this is one full wave for sine. Okay, so you can do it this way. And so if that's how you determine what you want to start with, then you would say, I see a sine wave. So you would say a sine bx minus c plus d. And then you would have the same amplitude and period and vertical shift. A is still going to be 3. The b value is still going to be pi over 2 because the period is still 4 units along the x-axis, and d is still going to be shifted up 2. And then the thing that's different here is because the beginning of your sine wave wasn't right on the y-axis, this does have a phase shift. Okay, the beginning of the sine wave started left 1 of your y-axis, so our phase shift is left 1. And so what you would do is you would set, so our phase shift is left 1. So you would set that, our left 1, equal to c over b, so opposite of c over b. So we'd have it equal to c over b. We know that b is pi over 2, so negative 1 equals c over pi over 2, and you would solve for c. So we end up getting that c equals negative b over 2. And we're going to substitute that back into our equation with all of our other values. So we get y equals a sine b, which is pi over 2, x, and then we have minus, here we got minus c, we also have a minus here, so minus a negative is going to become plus pi over 2, which should make sense because this graph is shifting to the left, and so when we shift to the left there's usually a plus inside the parentheses. Okay, so that is our equation. So hopefully that gives a nice little follow-up to our investigation. All right, so what we are really working on today is something called periodic functions, and it's really piggybacks off of what we were doing with the unit circle. The questions are just worded kind of differently, but it's finding the 6 trig functions based on a given point. All right, so what the questions look like is a little weird. It's going to say something like this. Angle theta has a terminal side that passes through the point, we'll say 4, -3. And then you'll be told find the 6 trig functions. For theta. All right, so like I said in our previous videos, when in doubt, draw it out. So we are going to draw a little picture of what is going on. So all of our pictures for trig are going to start with an x and y axis. So you're going to make a little axis. And I'm going to plot the point 4, -3. So 4, -3. Ooh, it would help if I went the right way. 4, -3. Okay, so there's 4, -3. And we are going to make a triangle. So 4, -3. I'm going to make my triangle with a hypotenuse starting at the origin and then going through the point 4, -3. Now what we are told in the problem is that there's an angle theta that has a terminal side that's passing through the point 4, -3. So what that means is if you think about our unit circle, we are going to always start at 0, and this angle is wrapping around and ending on that green ray that I just drew there. So here's angle theta. What we learned when we talked about the unit circle is that we have a lot of angles that have the same sine and cosine values in terms of the numerical value. Just their sine and cosine, the answers for sine and cosine just might change in terms of whether they're positive or negative depending on what quadrants they're in. And so we talked the other day about something called a reference angle. So theta is going to have the same sine or cosine as this angle right here, which is its reference angle. Okay? So in order to actually find the sine, cosine, tangent, cotangent, secant, cosecant of theta, what we're really going to do is find all of those values using this reference angle that I just shaded in. So to do that, I'm going to make a little triangle right here, which it doesn't want to connect to very well. But that's going to be a little right triangle. And I know that the sides of that are 4 and 3. And if I want to find the hypotenuse of that, we can do a little Pythagorean theorem. And like I said the other day, I hope you recognize that that is a Pythagorean triple and that you don't actually have to do this work, but a squared plus b squared equals c squared, and we get 16 plus 9 equals c squared, and that's 25 equals c squared, and so square root it, you get 5 equals your hypotenuse. But that's a 3, 4, 5 right triangle. All right, so once you have all that, you can do sine. Okay, so the sine of that's going to be the same as the sine of this angle in the triangle. All right, and sine's going to be opposite over hypotenuse. But we are in quadrant 4. And in quadrant 4, sine is negative because we've gone down. So in that regard, if you want to keep the negative on that 3, you can, because it kind of helps you remember that in quadrant 4, sine is going to be negative. I know the side of the triangle is not actually negative because that doesn't make any sense, but it helps you remember that on a whole big unit circle, that's the ugliest circle I've ever seen. There we go. On a whole big unit circle, that you're going to actually have a negative sign value. All right, cosine is going to be adjacent over hypotenuse. And cosine is positive in quadrant 4, so we keep that positive. Tangent is going to be opposite over adjacent. And then we need all 6, so we're going to do cosecant. So we're going to do the reciprocal, so that's 5 over negative 3. Secant is going to be 5 over 4. And cotangent is going to be 4 over negative 3. Okay? All right, let us try another one. So angle theta has a terminal side passing through. Let's do -1. Let's do -1, 4. Find the 6 trig functions. All right, so we're going to go back 1 and up 4. And there's your point. Okay, so again, here's theta. Now, if you want to find all the values for theta, we are going to use this reference angle right in here. So you want to make a little triangle. We know that the values for the sides of this triangle are going to be 1 and 4. And you can put a little negative there because you're going left 1, up 4. To find the hypotenuse, we're going to do Pythagorean theorem. 1 squared plus 4 squared equals c squared. So that's 1 plus 16 equals c squared, so 17 equals c squared, so square root of 17 would be the hypotenuse. All right, so the 6 trig functions. So sine is going to be opposite over hypotenuse, so opposite our little reference angle. We shouldn't leave a square root in the denominator, so I'm going to multiply top and bottom by root 17, and we get 4 root 17 over 17. Cosine, adjacent over hypotenuse. So same thing. So we get negative root 17 over 17. Tangent, opposite over adjacent is just -4. And then do all the reciprocals. So the reciprocals are really easy if you don't do the final answer in this case, but do these guys here, because that's going to just put our square roots on top. Okay, so cosecant is just going to be root 17 over 4. Secant is just going to be negative root 17 over 1. And then cotangent is going to be -1 4th. Okay, and that's really all the new information. We're going to practice some of this, as well as practicing using our unit circle for much larger angles and using our reference angles in class, and then hopefully have some time to work on your project. And don't forget, another unit circle quiz, and it will be using your unit circle to answer actual questions. Like, what's the cosine of 11 pi over 4? Something like that. So don't forget to be studying your unit circle. Okay? But until next time, peace out.